Evolutionary Computation. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. Quantum computing hopefully is the future of computing systems. It's still on its first steps. The development of some quantum algorithms gives the quantum computing a boost on its importance. These algorithms, such as Shor's and Grover's algorithms, prove to have superior performance over classical algorithms. The recent findings, that quantum error correction can be used, showed that the decoherence problem can be solved and hence the quantum computers can be realized. The quantum algorithms are based on the use of special gates applied on 1, 2 or more qubits, quantum bits. The classical computer uses different gates, not, and, NAND, or and XOR. Quantum gates are in many aspects different from classical gates where all gates must be reversible. This makes the quantum gates act as 2 and x2 transformation operators, where we have ninput bits and noutput bits. To understand the quantum bits and gates we describe the group of amplitudes that describes the state of a quantum register as a vector. A qubit with state vertical bar 0, which is guaranteed to read logic 0 when measured, is represented by the vector 10, and a qubit with state vertical bar 1 which is guaranteed to read logic 1 when measured is represented by the vector 01. An arbitrary qubit state is then represented by the vector alpha beta, as where alpha and beta are complex numbers and vertical bar alpha vertical bar 2 plus vertical bar beta vertical bar 2 equals 1. One important quantum gate is the Automar Gate given by when the input is vertical bar 0, Automar Gate changes the state of the qubit to who. That is vertical bar phi equals 12 vertical bar 0 plus 12 vertical bar 1. So when reading the qubit at the end, we have exactly 50% chance of seeing a 0, and an equal chance of seeing a 1. Generalizing the above example, if an input's register originally contains the value vertical bar 0n, it can be transformed using the Automar Gate to the superpositional state, where we would see each of the two binary numbers with equal probability when we observe the register. Other gates operate similar to Hadamard Gate with different matrices, where Pauli gates are given by and phase gates. The quantum computers use quantum gates to produce results in a faster and more efficient way than the classical computers. Implementation of quantum computers is still in its very beginning state, therefore, in this lecture, we need not to worry about the implementation issues. In addition to entanglement, the strength of quantum computing comes from the parallelism feature of the quantum computers and the fact that the quantum state is a superposition state. Using classical bits and bit vector can represent one of tune symbols, but in quantum bits and qubits vector can represent the tune symbol simultaneously. Quantum algorithms are usually organized in the following 3 steps. Step 1. Initialize the quantum states. Step 2. Apply the Oracle quantum core as many times as needed. Step 3. Measure the output states, results. In many classical algorithms, especially those used for searching mechanisms, speed and complexity are the main limiting factors in their implementation. The Terbi decoding algorithm is an important algorithm that is used to decode the received data when using convolutional or turbo codes at the transmitter. These codes are superior in their performance over many other types of codes. In the following we devise a quantum algorithm to implement the Viterbi algorithm, VA.